Newton's third law is, forces always occur in pairs. If an object A exerts a force on another object B, then object B exerts an equal but opposite force on A. If, for example, a force F is exerted on a solid wall, the wall exerts a reaction force of equal magnitude. The ability of a wall to resist an external force is assumed to be infinite here. The reason why this law is imperfect is as follows: if the ability of the wall to resist an external force is less than the external force, then the wall cannot resist the external force and collapses or moves backwards. At this point, it generates a reaction force that is less than the action force. Newton's third law is therefore only valid in the field of statics, i.e. it applies when the resistance of the body under attack is considered to be infinite. In the principle of inertia, we explained that an object in motion generally has an inertial force. Its task is to resist the action of external forces in order to maintain its state of motion. The magnitude of the inertial force is always equal to the magnitude of the external force if the external force is not greater than the maximum value of the inertial force. The action of an external force smaller than the inertial force cannot change the state of motion of an object. If the external force is greater than the maximum value of the inertial force, part of its force cancels the inertial force, and the remaining excess force acts to change the state of motion of the object. This means that if the external force is not greater than the inertial force of the object, the reaction force is equal to the action force. Newton's third law must also be supplemented by the rule of inertia in order to be perfected, especially in dynamics and kinematics. In a nutshell, all three of Newton's laws actually describe the laws of motion of bodies only in special cases. If they are supplemented by inertial forces, then Newton's laws can be applied to motion in general, that is, they are generalized.